Okay, so we're first going to start off in your postulate theorems definitions notes, and we're going to write the theorem proportional cuts theorem. So if you want to hit pause, write this down real quick, but we're looking at the proportional cuts theorem. Okay, now what it says is if three or more parallel lines, so we have three or more parallel lines, intersect two transversals, they divide the transversals proportionally. Okay, so what that's saying is when I divide up, let's say we had three parallel lines that cut two transversals, then they would cut it up in such a way that if we formed ratios between the corresponding side lengths, okay, those ratios would be equal. They would be cut proportionally. Okay, for instance, maybe I have parallel lines. Let's call this L, M, and maybe N. Okay, and they cut these two transversals. Whoops, let's try that again. They cut these two transversals here. Okay, this guy and maybe this guy. And the transversals don't have to be parallel, but let's say that L, M, and N are parallel. So L is parallel to M, which is parallel to N, okay? Then let's say that the points where we're intersecting here, let's call this guy A, and let's call this one B, C, D, E, and F. Okay, now if we have these three parallel lines that cut these two transversals at these points A, B, C, D, E, F, all that's saying is that if we form ratios between the corresponding sides, those ratios would be equal. Okay, the cuts would be proportional. Okay, let's say in this case then that AB, so if I take AB's measure over BC, okay, so let's just kind of look at that real quick. Let's maybe use orange here. So if I take AB's measure over BC's measure, okay, proportionally then, when I cut the other transversal, its corresponding parts should also, the ratio between them should also be equal, okay? In this case, the corresponding parts, let's use yellow here, would be DE over EF. So if I set those up as ratios, they would be equal to each other. So the ratio of when we have AB's measure over BC would be equal to DE over EF because they would have been cut proportionally. Okay, so this would be equal to DE over EF. Okay, but that's not the only one we can have. There's multiple different ones we can run into. For instance, we could also say AB over AC. And that would equal, so let's just break down the part first. So AB over AC, that would be the same thing as DE over DF. Well, let's use purple, okay? DE, okay, so notice that singular part over DF. Okay, so that would be the same thing as DE over DF, okay? Or another one we might see is like BC over AC. Let's try that one. BC over AC. Okay. BC's measure, which is in here, over AC's measure. Okay. BC's measure over AC's measure, which I kind of went too far there. There we go. Okay. BC's measure over AC's measure, what would that be the same as? What are its corresponding parts? Well, that would be the same thing as EF over DF. EF over DF. Okay, so BC over AC would be the same thing as EF over DF. Those ratios would be the same, okay? So that's all it's saying there, okay, guys, is that if the three or more parallel lines intersect by two transversals, it divides the transversals proportionally. In other words, the ratios between corresponding parts would be the same, okay? Now, for your purpose, if you need to, you don't have to have all these middle lines in there, although I wanted to keep that as E. There we go. You don't have to have all these lines in there. I just wanted you to be able to see what was proportional and what was not. But now we're going to transition into the set of notes of proportional parts. And notice this first part here is talking about what we just talked about, which was the proportional cuts theorem, okay? That's what we just talked about. Like they're going over the same types of ratios here. It says BC in here over CD is the same thing as GF over FE. Okay, so it's going over the proportional parts too, okay? Or another good one might be like they say AC, I'm going to use red. I'm going to look at this one here. AC over BD would be the same thing as AF over GE. Okay, so just as long as you know that the corresponding ratios between the parts, they're proportional and they'd be the same. So the ratio of AC over BD with its that ratio would be equal to its corresponding parts of AF over GE. Okay, now first of all, let's be able to recognize what the corresponding parts would be. Okay, so in this example, it says we want to find the missing piece over here. Okay, the missing part that should make this two ratios, this statement true here. So it says BY over BD. Okay, BY over BD. Well, if they're giving us TM over here, shouldn't the corresponding part be TE? Yeah, and that's what they're saying here is TE. Okay, so BY over BD is the same thing as TM over TE. Okay, now the next one says AY, so let's find AY, which is over here, over AM, so on the other side, so AY over AM, that's the same thing as DY over what? Well, AY over this guy AM is the same thing as dy. Well, its corresponding part should be over here, which is em. So the corresponding part should be em, which is what they say there. Okay. Now, last one, just to recognize the corresponding part, it says TE over BD. Okay, so TE is over here over BD, so its corresponding part there. So TE over BD, that's the same thing as blank over AD. Let's find AD. AD is right there, okay? So TE over BD should be the same thing as the corresponding part over here, which would be AE over AD, okay? So AE over AD, which is what they say there, okay? So be able to recognize where the corresponding parts are so that you can complete the proportions. So we have the right proportions that say which ratios are equal to each other, okay? Once you understand that, then that allows us to be able to actually solve or use the relationships to be able to solve for a missing length, okay? Possibly in the form of they give us X or Y. Now, when I look at this example here, let's take what we just learned about the relationships between the corresponding parts and see if we can set up different proportions here to help us be able to solve for X. Now, there are many different ways we can set this up, and they actually give us a few of them here. They say we could say that this part, 6 centimeters over 5 centimeters, would be the same thing as 4.5 with its corresponding part of X. That's what they're saying here. 6 over 5 would be the same thing, or should be the same ratio in terms of 4.5 over X. In other words, that would be our proportion. That's one way that we could solve for this. Another way we could think of it, they say, is X over 5 should be proportionally the same as 4.5 over 6. That's another way that we could solve it. We can also think about it in terms of totals, okay? 5 over this total side length, in this case, the total side length would be 5 plus X, right? Because they don't tell us the total length here, so the distance between here and here would be this distance of 5 plus X. So 5 centimeters over the total length of 5 plus X should be the same as 6 centimeters over the total length. Well, to find the total length, we would take 6 plus 4.5. What's 6 plus 4.5? 10.5. So that would be the same thing as 6 over 10.5. Okay, so that's another one that they show us here. 5 over the total length of 5 plus X would be the same thing as 6 over 10.5. All of those are valid ways that you could solve for X, okay? But I'm going to focus on the first one. Let's just focus on the first one, which said that 6 over 5 is the same thing as 4.5 over X. Okay, those corresponding parts that would help us set up this proportion, which would have equal ratios. So then we could use our cross multiplication. We'd have 6x is equal to 5 times 4.5. We'd have 5 times 4.5, okay, which comes out to be 22.5, okay. Then when we divide by 6, whoops, all right, there we go. Then when we divide by 6, we get 3.75 centimeters, okay, which is also what they have here, okay. So we get x is 3.75 centimeters. So that would be this part here, 3.75 centimeters, okay. So that would be one example. Another example over here. Again, there are many different ways we can set this up or set up a proportion in order to solve for x. Now, one of the ways we could do it is we could say that 1.2 over 1, the ratio between those two should be the same ratio of x over 4. Okay, so 1.2 to 1 should be the same thing as x over 4, which is what they set up here. Then we would just have cross multiplication. Okay, so then we have 1.2 times 4. And then 1 times x. Well, 1.2 times 4 is 4.8, which is equal to 1 times x, which is just x, so that gets us to here, okay? So x is equal to 4.8 centimeters, okay? That's one way we could solve it. We could also set it up in different ways. We could have said 1.2 over x is going to be the same thing as 1 over 4. There's different ways we can get to the same answer, okay? Now, this next example here, they're actually going to use the total length and keep that as a part of, or use that as part of the proportion here. Now, one of them that I see, let's use red, is this length right here of 5 over the total length of 9, okay? That ratio of 5 over the total length of 9. Now, that's one ratio that we could use, and that's what they're using here. However, we also have to use the corresponding parts. Okay, so if I use 5, then I need to use 6 over this total length. Well, notice we don't know what x is, so how do I find the total length? Well, that would just be 6 plus x, right? So if I'm writing the equal ratio, it'd be 6 over 6 plus x. That's what they have right here, okay? So 5 over 9, the total length here, which is 9, would be the same thing as 6 over the total length. In this case, the total length would be 6 plus x. Okay, so then we can use that as our proportion, and we could cross multiply. We'd have 5 times 6 plus x and 9 times 6. Well, this is going to get us to the distributive property here, and we have 5 times 6, which is 30, 5 times x, which is 5x, and then 9 times 6 was 54. Okay, subtracting 30 over, we get 24, divide by 5 from both sides, and we get x equals, that doesn't come out 9. Okay, they tell us here it's 4.8, so we could divide it in our calculator, we'd still get 4.8 centimeters. Okay, so we get that x is 4.8 centimeters. Okay, now the last type of situation we might run into, which kind of reminds us when we're dealing with similar triangles when we're working through those problems, but it's a common mistake that some people often make, and they're trying to point this out to you, okay? So when we look at this guy here, if we wanted to solve for x, a common mistake people often make when we're writing our ratios here, they might say 5 to x here. That's fine. 5 to x, that's fine. But the mistake they make is then they do 7 to 14. Why would that be wrong? Well, notice 14 is only this side length here. If we're actually talking about its corresponding part, that would be the total length. Notice this is 5's length to the total length here. So if I'm using 7, then I need the total length here. So instead of 14, I need 7 plus 14, which is 21 centimeters. So this proportion over here that they say 7 to 14 equals 5 over x, that doesn't work. They say that's incorrect. Okay, so that's why it's big and bold here. That doesn't work. If we're going to use 5 over x, then we need 7 over the total length, which would be 21. So the actual proportion we want is 7 over 21 equals 5 over x. And they try to show you visually how we're using the small triangle here. Maybe I'll use a different color, in orange. This small triangle here, and the larger triangle here. Okay, so the side length would be 21 over x, and this side length over here is 7 over 5. So if we write the corresponding parts, then it'd be 7 over 21 and 5 over x. So then we can solve that proportion there. Okay, so cross multiplying. Okay, so cross multiplying on this example here, we'd have 7x equals 21 times 5, which comes out to be 105, divide by 7, and we get x is equal to 15, okay? So we get x is equal to 15 centimeters, okay? So that's how, don't make that mistake. That's how we want to work through those. It's kind of similar to that idea when we were working with similar triangles there.